second video blog at Lanner Electronics. Today I'm pleased to have one of our partner companies presenting what's special on SD-WAN on their solution. And in particular, we want to talk about, what are tunnels for? Because SD-WAN is, there's a lot of hype about resources and networking. Please welcome Ritesh from 128 Technology. He's VP of Product Management, and he is driving the solutions together with 128 for some of the deployments we have done together. So Ritesh, welcome, and give us a quick run through who 128 is, what's the vision, and what's so special on using 128 over the traditional SD-WAN solutions.
Hey Sven, thank you for having me. Yeah, definitely. I mean, we have got some good material today to cover. One, I want to talk about how we are doing tunnel-free SD-WANs. It is not a pipe dream anymore. It is reality. We do have tunnel-free SD-WANs, and we have deployments today on Lanner devices which run and of course power some of the largest enterprise and service provider deployments today. We'll talk about that as well. But to answer your question, who's 128 and how we do tunnel-free SD-WANs? So we are known as 128 Technology because we are based on Route 128, which is in Boston. We have about 300 plus customers globally. We have about 120 employees. We have raised 100 million in funding, and we have about 50 patents. Most of our customer sites range from a couple of hundred to thousands of sites. The difference between any other SD-WAN or routing technology and us is that we are session-based. So we work on sessions instead of packets, and we keep dynamic sessions straight per flow. That enables us to remove tunnels. We don't need to have encapsulations or overlays per packet. We can do encryption and authentication, and we have FIPS 140-2 certification for that. But we don't need to add a per packet overhead, per header overhead per packet. So we don't need to add a full IP header per packet, and that saves about 30 to 50% bandwidth depending upon the packet size. Let's look at some of the benefits of using tunnel-free SD-WANs. One of them is massive scale. Because we do not use tunnels, we can have really high scale and performance. One of the limitations of having tunnels is you cannot have a large number of tunnels per branch router. Even the best branch routers today from our competitors do about 1,000 to 2,000 tunnels at best, which means you can make a full mesh of about 100 sites at best. In our case, you can have thousands of sites in a full mesh or in any-to-any connection, and you can still run them without any issues. So it's very high scale. Also, because you have to do hub and spoke technologies in many cases, in our case, since you don't have tunnels, the amount of branch routers you can maintain at a head end is about 3 times of anybody else. And our hardware performance, the performance we get on these Lanner Whiteboxes, is about 4x of any other solution out there in the marketplace. And this has been tested and verified in this Tolly test report, which I have a link to here, and we can provide links to it on our website as well. But it's actually on Lanner hardware, the test has been done, and it shows the scale and performance benefits we get. And one of the things I wanted to highlight is our zero-touch capabilities on these devices. One of the deployments we have done in which we have deployed about 70 to 80 sites or almost 100 sites a night, and we really brought up 5,000 site network in less than a year with dual routers in every site and zero downtime. So we have massive scale benefits because we do not use tunnels. The other is breakthrough economics. Because we don't use tunnels, you can save on bandwidth costs. This means you don't have to buy bigger bandwidth pipes. Your connections work better over satellite and LTE or skinny pipes. You also have to pay less to your public cloud providers because they charge you based on the bandwidth you're going to get in and out of the cloud. So you lower your bandwidth costs by about 40%. And since we can get better scale on low cost hardware or higher scale on same priced hardware, so it lowers overall your hardware cost. For example, you don't need bulkier head ends now. You can go with smaller head ends because you don't need that much power on the head ends because you're not terminating tunnels. So overall, we believe this lowers your hardware cost by 75%. And ultimately, because of all the zero-touch provisioning capabilities we have, this brings a lot of CapEx and OpEx savings. Again, we have a third-party research paper which has been written, and you can read it for more information. One of the benefits of not using tunnels and having in-band signaling is that we have seamless application connectivity. So we can connect any session over any device through any medium over any address family to any network boundary. What that means is we don't care what the underlying network is, whether it's MPLS, internet, satellite, microwave, LTE, 5G, or if it is changing networks in the sense it's going from MPLS to internet and so on in the path. We can go through all of them because we don't need other signaling protocols because we have in-band signaling and we don't use tunnels. Those are some of the benefits of session smart routers.
So that means that actually deployment it's much more scalable, because when you can reduce 75% on the hardware cost, that's a big improvement, because normally the biggest portion in the cost point is normally the hardware, right? So you can reduce that significantly, I guess.
Absolutely. The biggest cost is hardware and connection costs, obviously. So we are bringing both of them down significantly. And if you're using public clouds, obviously you're going to save monthly by not having to pay the public cloud providers that much for using for bringing traffic in and out of their public clouds. So yeah, overall, this is definitely going to help your entire solution. It's going to be much more scalable, like you said, and of course, much more cost effective.
Excellent.
Do we want to talk about one of the deployments we have done on these Lanner devices? I think it's one of the biggest SD-WAN deployment on the planet today.
Yeah, definitely. Let's take a look on what we've done together.
So one of the big deployments which we have done jointly along with Lanner and 128 Technology is for an auto parts retail store in the US. They have about 5,000 stores and they wanted to have superior connectivity. One of the challenges they really face is that every time a store is down, the network is down in the sense, and they're unable to take calls. For them, every call is worth about $100 because someone is going to order an oil change, a tire change, or some kind of service. And so they don't want to lose these calls because it directly leads to loss in revenue. They also want to have 100% uptime per store. They want to reduce their bandwidth usage. They want to reduce costs, simplify the stores. Currently they're deployed on us. Their previous network had a large number of devices in the store. For example, they had load balancers, routers, switches, firewalls, WAN optimizers, and VPN concentrators. This made their network extremely complex in the store. They wanted to have a simple store network with 100% uptime. They chose the Lanner hardware and the 128T software, and they're utilizing it today. They have 3 connections per store, MPLS, broadband, and LTE, and they work as backups of each other. We're going to talk about how it works. They have zero-touch deployment. I mentioned already that we deployed about 70 to 80 stores per night. They have fully redundant voice connections. They have HA per store. They have 2 Lanner boxes working in HA mode, and they can add, modify, remove services dynamically. Some of the benefits that they got, and I'll quantify them in a later slide, but the main idea is to prevent revenue loss. So they want the calls not to drop. And of course, they want to reduce their connectivity costs. Everyone wants to reduce CapEx and OpEx, and that is true for them as well. This is how a store design looks like for them. So they have these 2 Lanner devices running the 128 software in HA mode. One of them is connected to the MPLS VPN network, and one of them is connected to internet. The one which is connected to internet also has an LTE backup in case we want to get into the box, or if everything fails, then they have wireless connectivity for that. They still have kept their switches in the store, and they connect everything through those switches to the 128 devices. The point of sales terminals, their voice calls, any other guest Wi-Fi, everything is connected through the 128 routers. The voice calls are normally directed towards the MPLS VPN traffic, and all internet traffic or any other traffic goes over internet directly towards the internet, obviously. And in case of failures, we of course have backups. Each of the connections work as backups of each other. And in final, of course, if we lose all the wired connection, we have wireless as well. Wireless also helps us to do zero-touch provisioning. They just plug the router in, and of course the SIM card connects to the wireless network, and they reach out to the conductor, and obviously they can do zero-touch installations in any store without the requirement for having IT present at every store. They can just ship boxes there and plug them in and get going.
And the goal here is to actually use a white box with running multiple applications, right? So 128 is not the only one in the equation here of the solution, right? So there are different elements to it, right? So how did you?
There can be any other VNFs running as well. Do you want to talk a little bit about the Lanner units they're using in these deployments?
Yeah, they're using a Lanner Whitebox. It's basically an Atom-based. It's an Atom-based family, which is a multi-core CPU with multiple networking interfaces, and it's supporting most of the protocols needed for that. Including quick access technology from Intel or SRIOV support for the visualization layer. But the key here is that 128 provides all the networking infrastructure for the tunnel-free networking. But there are also interaction where other applications can reside on the same platform next to the 128 solution. So that's a big difference on a white box approach rather than doing a deployment with a purpose-built appliance. So that makes it much more scalable, adding new functionality, new VNFs. So that's the element here from our point of view for the scalability aspect.
Let's talk about some of the benefits, the end user benefits at the end of the deployment. We rolled out, of course, 5,000 stores in less than a year. Like I mentioned, we probably think that's some sort of record. The stores have 100% availability for voice and data. The green line that you see, 100%, and of course there's another line behind it, which you can't see, but that's 2 lines. They're all 100% up all the time. The blue line shows the failures in connections, and the orange line shows the time it took to repair those connections. But having said that, as you can see, even if connections go down, voice and data is up 100% of the time. We took the snapshot end of last year, just after the deployment was done, to see how the stores are performing, and as you can see, all of them are up 100% of the time.
Yeah, so the HA functionality is a big element on that because these stores are all over the states, and there are no IT personnel to do a quick reboot or troubleshooting. So that HA functionality definitely brings it up to a high upturn.
Absolutely, and also HA gives us the ability to upgrade routers. We can put all the traffic on one of them, upgrade one, and then switch over like in-service software upgrade. So it provides us the ability to troubleshoot and debug a router while the other is forwarding traffic. So definitely HA helps. It helps to make it 100% available. Also, another thing which we noticed is that there was 90% reduction in tickets for the customer. The customer has also seen a revenue increase of $6 million, and they attributed directly to having calls not dropped or the 100% uptime which they have. So they can get all the calls, they can service the calls, and they have happy customers at the end.
Good.
That's what we had for a deployment standpoint. I'll let Sven talk about some of the white boxes they have from the Lanner perspective.
Yeah, of course. It's like when you buy a car, right? If you don't have any tires and the right tires to drive on it, you won't be able to use a car. So in our case, we are the underlying hardware for that. So we created a portfolio for white boxes. These white boxes are really predefined for SD-WAN deployments primarily, scaling from extra small, small, medium, large, and extra large. The unique thing is here that the 128 technology solution can be running on any of these devices, because if it's a small or medium or large enterprise, you can scale. So there is no need to call your dedicated purpose-built vendor and ask them to replace a physical appliance. We can scale using that approach of a white box. And of course, time to market is also a big aspect on that. So yeah, so I'm happy it worked out, and I think we have a couple of more projects in the pipeline, and
Yes.
And very exciting times for SD-WAN. I think it's the most growing industry at the moment. And I'm looking forward to build more of these solutions together with 128. And thank you very much for joining me here on the video blog. And
thanks so much for having me. No, we really appreciate the partnership with Lanner, and this is just a testament of the good work we are doing together, and with happy customers and happy end users. And I hope we can continue to do that again.
Absolutely. Thank you, Ritesh.